For the launch of Columbia on Space Shuttle mission STS-62 is continuing on schedule this morning. We're currently in the standard 2-hour built-in hold at the T-minus 3-hour mark. Launch of Columbia on mission STS-62 remains on time to occur again at 8:53 a.m. Eastern Time from Kennedy Space Center's Pad 39B. And we have live video of the crew at breakfast. Seated in the center is Commander John Casper. On the end we have our mission specialist, Pierre Thuet. And seated next to him is our pilot today, Andy Allen. Again, Commander John Casper. Mission specialist Sam Gaymar. And rounding out the 5-member crew is the lone female on board today, mission specialist Marcia Ivins. All 5 members of the flight crew were awakened at about 4 o'clock this morning. Following breakfast, they will be given a briefing of today's launch time weather and start putting their flight equipment together. This is shuttle launch control at T-minus 3 hours and holding. The ICE team continues to make their assessments of any abnormal buildups of ice or frost on the external tank and other shuttle components. Currently, they are standing on the mobile launcher platform, upon which rests the external tank, the solid rocket boosters, and of course the orbiter itself. We have about 20 minutes remaining in our hold this morning, and we're standing by for a live video of the crew donning their flight suits. And we do, in fact, have video of the crew in their crew quarters, which is located in the Operations and Checkout building at the Kennedy Space Center's industrial area. Commander John Casper preparing to make his 3rd trip into space today, putting on his communications cap. Casper is from Greenville, South Carolina. And he'll be flanked by our pilot today, Andrew Allen, who was born in Philadelphia. Andy Allen is making his 2nd trip into space today. And writing a hello to Jessica and Meredith. Taking a more relaxing pose, of course, is another member of the flight crew. And Marcia Ivins sees herself in the mirror sees herself on NASA Select TV. And she looks ready to go. They've all been in town since this past Monday afternoon. Marcia's making her 3rd trip into space today. Mission Specialist Sam Gaymar has just picked up what might be the 6th crew member. This is Theodore Tracy, and he is given to the crew by the students of the Gulf Gate Elementary School in Sarasota, Florida. Of course, we're checking on the status of his health stabilization. Mission Specialist Sam Gaymar, again one of 5 crew members that will be flying today. Sam's prepared to make his 3rd trip into space. Back to our commander, John Casper. This is shuttle launch control, and we are at T-minus 3 hours and counting. crew are exiting the crew quarters at this time. Commander Casper, pilot Andy Allen, mission specialist Marsha Ivins, Pierre Thuet, and Sam Gaymar. The crew have arrived in the White Room, and Commander John Casper is presently being suited. He will be the first to enter the vehicle. Piloting our flight today will be Andrew Allen. He is being assisted right now and making final preparations to be placed into the orbiter. He was selected as an astronaut in 1988 and is making his second flight into space today. Mission specialist Pierre Thuet is making his third space flight today. He'll be the next to enter the orbiter. Mission specialist number 3, Marsha Ivins, is making last-minute checks before she prepares to enter the vehicle. Sam Gaymar is mission specialist number 2, and he will be the last to enter the vehicle this morning. The other is already in their seats at this time.
Understood here, loud and clear, Bob.
Okay, John. Well, it looks great down here. Hope to give you guys and Marsha a great ride here in a few minutes.
Okay, well, just want to thank you, Bob, and all the folks on the world's greatest launch team for all your hard work that you've put in to get us ready to go. And we're looking for a safe and successful mission on Columbia.
Well, thank you, sir. It's always a privilege and a pleasure. And the NTD go to proceed.
Hot copy, thank you. And the countdown clock will pick up in 2 minutes.
PLSs go for OAA retract.
The orbiter access arm is now being retracted away from the vehicle. This is the walkway used by the crew to gain entry into and out of the vehicle, and it can be returned to position within seconds if need be. T-minus 7 minutes and counting. A final gimbal of the main engine bells is now underway. This is a final check of the main engines prior to launch.
TLT OTC, clear caution warning memory, verify no unexpected errors.
Roger and work.
T-minus 2 minutes, 20 seconds and counting. All is ready to fly today on NASA's 4.5 million pound space shuttle vehicle.
Caution warning is complete.
Thank you.
Orbiter test conductors requested that Andy Allen clear the caution and warning memory system, and that has been reported complete.
Flight crew, close and lock your visors, initiate O2 flow, and have a...
T-minus 2 minutes and counting.
Roger, that's in work, and thank you.
Okay, let's go for ET LH2 pressurization.
Everything continues to look good for launch this morning. In about 90 seconds, the Space Shuttle Columbia will begin its 14th day extended duration orbiter flight, one of the longest in space shuttle history.
1 minute 30.
T-minus 1 minute and counting. T-minus 50 seconds, and we're transferring to orbital internal power at this time. Columbia is now running off its 3 onboard fuel cells.
Okay, let's just go for auto sequence start.
And we have a go for auto sequence start. Columbia's onboard computers have primary control of all the vehicle's critical functions.
20.
T-minus 20.
15.
15. 11. 10. 9.
Okay, let's
8.
go for main engine.
7. We have a go for main engine start. 4, 3, 2, 1. And liftoff. Liftoff of the Space Shuttle Columbia as NASA continues on the cutting edge of microgravity research.
Houston's now controlling.
And Houston.
Roger, roll, Columbia. Mission Control sees a good roll maneuver, placing Columbia on the proper heading. 3 good engines at 104%. Three engines are throttling back now, easing the buildup of aerodynamic loads as Columbia continues to accelerate rapidly through the dense lower altitudes. 3 engines now at 67%. Columbia is traveling over 500 miles an hour at 52 seconds. All systems are performing well.
Columbia, go at throttle up.
Roger, go at throttle up.
All 3 engines are now running at full throttle. All systems are performing well. Altitude is now 59,000 feet, downrange distance 7 nautical miles. Columbia is traveling over 1,000 miles per hour at 1 minute 29 seconds. Columbia continues to climb at a relatively steep angle at this point, relying heavily on the solid rocket boosters to triple its rate of speed over the next 60 seconds. Delivering a combined 6.5 million pounds of thrust, the boosters will burn out and separate at 2 minutes 6 seconds. Time now 1 minute 48 seconds. All systems are performing well. Altitude 116,000 feet, downrange distance 18 nautical miles. Mission Control sees a good booster separation. Columbia is now flying free, powered by its own main engines. Second stage guidance is now in control. Altitude 184,000 feet.
Columbia, performance nominal.
Performance nominal.
That's an indication that the boosters have done their job as designed, and the main engines as well. Altitude is now 198,000 feet, downrange distance 44 nautical miles. Columbia is now traveling over 3,000 miles per hour. This is Mission Control Houston. We're taking live television through the Goldstone Tracking and Television Station in California as Columbia completes its first orbit of the Earth on this 14-day mission. Currently, the crew is in the process of opening the latches of the payload bay door along the center line. Once the center line latches are all confirmed open, the bulkhead latches, both the forward and aft, will be opened. And once they've been unlatched, the motor drives will be commanded to begin driving the doors open. As at this point, the starboard payload bay door is in motion.
Okay, here's your ET photo DTO.
That we have good downlink, and that's some tremendous camcorder footage.
External fuel tank later re-enters the atmosphere over the Pacific Ocean and burns up before reaching the surface.
Tell you what, Pierre, your ET photo downlink has had everybody just captivated down here. It is just absolutely awesome.
Up until that point.
That call from the crew indicates they're now starting to power up Columbia's mechanical arm, seen here in a live television from the spacecraft. Mission Control Houston, that television view from Columbia's lower deck showed mission specialist Sam Gamar working with the Advanced Protein Crystal Growth Experiment, or APCG, and activating the thermal enclosure system for that experiment, or TESS.
What our overlay has on it, the control team down there, has three circles, then basically two zones that are horizontal and vertical. And what we try to do is maintain the crosshair on our monitor on the red reflector in the middle, which is actually the image of the camera in the mirror. Then we try to keep the crosshair centered between the two reflectors on the left and right, as well as the one on the top and bottom, while keeping the crosshair on the image of the camera. And if we do that during this task, then we've accomplished the objective. So what we're trying to do is see how precisely we can do that. We use the zones on the overlay to determine the tolerance that we can fly the arm to.
and Pierre, we're real happy with the view. The EISG folks are going to send some commands shortly, and we should see some motion in the mirror.
Okay. There, something just flipped.
Yeah, we saw that.
Good close-up of our monitors. You were seeing a lot of times the same stuff we were seeing from those two displays. I had a real hard time finding the crosshairs because with the mirror and the sun, the display was really washed out, so it took us quite a while to find the crosshairs. We found the camera reflection right away. Sam just had it. Sam's flying. He had a hard time finding the crosshairs. Neither of us could see them for quite a while.
And it will be rotated to allow the flat panel portion to be inserted into the slot at the top of the carrier. And the insertion of that flat panel portion will be aligned using a camera that's on the side of the magnetic end effector at the end of the mechanical arm. This is Mission Control Houston. This live television from Columbia's payload base shows the taskbar for the dexterous end effector, and currently in work an insertion of it into the slot at the top of the carrier for the end effector equipment. The taskbar is being held by a magnetic end effector at the end of Columbia's mechanical arm. Once it's inserted into the slot, simulating a task that might be used in the future for space station construction with a radiator, the panel will be rotated to about a 30-degree angle both forward and aft.
Out in the bay here, you see on your left, just above the little American flag, one of our furnaces, semiconductor furnaces called Mephisto, and there's another cylinder over on the right. Those two furnaces are doing semiconductor crystal growth experiments, and the benefit there is better, higher quality, faster semiconductors, and that's used in making computer chips that go in all of our computers and telephones, wristwatches, and a lot of things that we use today. Now in the back, behind the Mephisto furnace, is another round, large, cylindrical looking experiment, and that one's doing a solidification of metals. And here we're looking at how metals solidify, with the potential benefit there being of making stronger, lighter weight metals to aid the automotive, construction, and shipbuilding industries.
This is Mission Control Houston. The lid is now opening for the limited duration candidate materials exposure experiment in the cargo bay. The LDCE experiment holds a total of about 250 samples of various materials that are under study for use in spacecraft, in building future spacecraft. And we'll study the wear experienced by them and how well they hold up in the low Earth orbit environment.
And John, we got the picture, John, and we see the door opening.
Okay.
This is Mission Control Houston. Once again, we're receiving some videotape replays provided by the crew of Columbia, orbiting 140 nautical miles above the Earth. Now looking at the opening of the instrument door for the Space Shuttle Backscatter Ultraviolet experiment.
And Houston, this is a picture of our little experiment on board. We're looking out the aft window, and through this little module, you can see the reflection of the Ohms pods and the tail. We heated this up in our galley here to get a little bit warm. But it's all a gas that we're looking inside here. As it cools down, this gas, which is Freon in this experiment, is going to go ahead and reach its critical point, and the temperature and pressure will come to this point that defines the critical point, and the properties of what we are looking at will change. This lasts a couple minutes, and I'll fast forward through a little bit of it. But let's go ahead and let it run for a second. We're starting to reach the critical point here, and there's the critical point. As the temperature continues to cool, the liquid and the gas will go ahead and separate again, and we'll go ahead and get ourselves back to the point that we can start seeing or get our transparency back through this little module. Set it up a little bit, but that's our final product. You can kind of see the fluid formed as a bubble in the middle there, but it's got all its translucency back. And we can go ahead and see back through the cell.
This is Mission Control Houston. Right now we're taking some live downlink television pictures from camera D in the payload bay. That's one of the low light cameras in the arsenal of cameras on board. The flashes that you see and the glow are thruster firings as Columbia maneuvers into a new attitude with its belly facing in the direction of travel. In the foreground, there's a diagonal plate running at about a 45-degree angle. That is the plate from the experimental investigation of spacecraft glow, which is looking at the interaction of spacecraft surfaces and atomic oxygen in orbit.
Columbia is now approaching the Midwest, and we'll cross off the northern east coast of the United States. Also moving into sunrise.